Welcome. Thanks for joining me. So first off, I don't see most of you because there's some lights up here which are blinding me. So from like row 5, 6 or up, I see there are people. That's about it. Uh, but today we're going to talk about reproducible environments using Nix, or how Nix could help us do that. Uh, in reality, it's kind of a badly disguised talk about Nix because I like Nix and want to talk about it. So I'm Martin. I work for Cisco. I do some programming stuff there. Uh, I really like Nix and been digging in that rabbit hole for quite a bit of time. Uh, During the presentation, feel free to interrupt me and ask questions. Don't bother raising your hand because, like I said, I can't see you. Just shout it out and I'll stop, and we might need to repeat it. But feel free to interrupt it. So let's talk a bit about reproducibility. What is it? Well, to talk about reproducible environments, it doesn't really make sense if we don't talk about reproducible builds. So a build is reproducible if any party can recreate any part, or bit by bit recreate identical copies of the artifacts, given the same source code, build environment, and build instructions. So you need these three components to be the same to be able to do reproducible builds. If any of them differ, then it's not going to be the same build. So source code and build instructions are something I hope a lot of people have at least some control over when they do their release builds. But their build environment are harder. How many here do actually have a reproducible build environment? Just realized I can't see you anymore. So yeah, but I did see some one hand or something. Now the question is also, is that reproducible a year from now, 5 years from now, or even tomorrow? Can you get actual bit by bit identical builds from the same checkout of your Git source tree tomorrow? Most people will actually struggle a bit with that. And this is where I think Nix can help us a lot. But of course, why do I want this? Why do I care about reproducibility? One of them is supply chain attacks. Like, you can actually verify that the thing you're building is the same that you thought you were building, that nothing has been introduced into the build. So to verify software legitimacy, but also like on a day-to-day basis, sometimes you want to change stuff in your build environment or in your build instructions or a build system without actually changing the build. You want to make a refactoring of your build system. And if you can't verify that it hasn't changed anything, how do you actually know that you haven't broken anything? And it might not break every time, but it might break like 1 out of 10 times. And that's pretty bad. And it's very hard to find out. So being able to reproduce your build, like bit by bit, you can do these refactoring safely because you know that if the actual end instructions hasn't changed, then you haven't broken anything, you just improved the code, like the build code. So what is an environment? What do you put into your environment? The compiler version, libraries you pull in, libraries you link with, build flags, environment variables, usernames, timestamps. There's a lot of things going on into an environment that might affect your build. So a lot of build environments, for instance, pull in the build user into the source code somehow. Which means that my user and a colleague's username are different. So if your build environment does that, then you need to make sure that you're using the same build user or the build username. There's also other stuff going into an environment. Randomness, basically, will have an effect on this as well. And the goal here is to set up an environment containing these things that is actually reproducible, that will not differ from me and a colleague of mine. And that's where Nix comes in. And Nix is many things. It is a programming language. It's a functional programming language. It's a package manager. It's a OS build system. It's an environment thing. Like it is a functional programming language which is built to be able to reproduce environments. And the natural progression of that is to make a package manager out of it and a package repository, and that's what has happened. And the natural progression of that, again, is to make sure that you can then build a full Linux OS. It is also a rabbit hole, and it steals your time, and you probably don't want to do this because you're going to spend far too many hours optimizing your OS. I do not dare to say how many hours I spent on this. It's lots of fun, but it does take some time, and it's a very steep learning curve compared to like setting up your regular Linux system that you might be used to. So you want to use Nix for this because it is declarative. It isolates every step of your build process, and by design it creates reproducible builds. Of course, it cannot force a build system to be reproducible, because what Nix does is when it builds, for instance, Vim, it uses Vim's build system. It sets up the environment for building Vim, and then it calls Vim's build system to build it. And if Vim's build system is not reproducible, then of course the build itself won't be reproducible. Nix can't fix that. But Nix runs on any Linux distribution and Mac. I haven't used it on Mac. I never used Mac, so don't know really how it works. And its easy is to add a custom package. Like I said, the learning curve for Nix is quite steep. You need to learn a new paradigm for how to set up a system, how to build packages. You need to get comfortable with functional programming languages. But once you get a bit up on that curve, it's kind of nice and easy to add new packages using that language. Now, of course, I might be brainwashed by this. I've spent many hours doing this. So when I say easy, might be like Stockholm syndrome or something, but it's doable. Now, I'm also going to introduce Nix Flake here, which might not mean anything for you. If you've been into the Nix ecosystem, you know a bit about it, but it's a standardized format which is using the Nix language to pin inputs, basically, is how I like to look at it. It's also in the experimental stage, which is it has been in the experimental stage for many years now. So even though it's experimental, a lot of people are actually using this. But since it's experimental, the developers might decide to break the feature, change core parts of the feature, and thereby break you, which is going to be fun when it happens. But I kind of like it. I think it's a very convenient way to work. So let's start looking at some code. And this is how flake looks like. And this might feel a bit overwhelming if you've never seen this before. What it does is it defines some inputs and some outputs. So every flake has a description. This is just a name. And then it has some inputs. And this input is the Nix packages package repository. I say I pull that from GitHub, and this is the path to those packages. And I want the Nix packages unstable branch, which is fine for a talk, but might be not ideal. And then I have a definition of my outputs. And this is a function. It takes two arguments. It takes itself and Nix packages. Then I do some convenience stuff to get the package repository for x86-64 on Linux. But the important parts here are packages and dev shells. So I make a package, which I just pull in from the package repository. And I also make a development shell. And this is how you define what's a package and what's a shell in flakes. And we'll go a bit more into details on how this looks, because now we're just hand-waving a bit. Now the nice thing about flake is that it creates a log file. So first time you build, it pulls down this Nix packages unstable branch from whatever is the current head. But then it pins that SHA. So next time you come to this, you're building everything from that package, or from that SHA in the Nix packages repository, and all packages will then be pinned. And this is also how you would do it for the full OS. Now, the assumption of reproducibility kind of breaks, which is kind of early to throw in the towel, I think, but there are some assumptions done by Nix which might not hold. Because Nix assumes that every step is reproducible, and obviously if it's not, then everything after the non-reproducible step will break reproducibility. So if there's a package which in its build steps reads something from dev view random, which is basically just some random numbers, then it's no longer reproducible, and like nothing following that package will ever be actually reproducible. But Nix assumes that it is and puts it in a cache. And the way you find out if your package is cached is that it hashes the inputs and then assumes that the output would be the same, which is logical if you're thinking it's actually reproducible. But if you're building everything from source at some point, then you might actually end up with different hashes. But there is also continuous work in Nix and in Nix packages to make sure that every build is reproducible. Every package should be reproducible. Their installer, their USB installer is 100% reproducible, and the goal is to get everything reproducible at some point. So setting up an environment is one step in getting a reproducible build. And the way you do that is you say, I want to grab these packages. These are the dependencies that I need for my build, and these are the environment variables I need to build. Which is kind of just a simple environment. And like I said, Nix does not solve reproducible builds for you, but it can help you set up a reproducible environment, which then can be used to make your builds reproducible. And one thing we want to make sure is that we don't want to lock packages in a way that stops the developers from being able to change or experiment with different versions, try new compilers, try new libraries. That should be easy to do still, even though we are putting everything into a somewhat rigorous system. But let's start looking at some more code. So we want to make a shell for our developers. And the goal is that every developer should be able to enter that shell, that environment. And in that environment, they have everything they need to build. It's a very easy way to set up a development environment, or for the developer that's actually using it, not for the one that's writing the Nix stuff necessarily, but for the person using it, it should be easy to enter the environment. You should have everything you need and should be able to build. And if that build is reproducible, then it should be reproducible. So let's have a look at how to change our flake to do that. And the only difference is we make a dev shell, and just for ease of reuse, we do this packages call package, which is a function call. /simple is a path on the file system, and I call that with 0 extra arguments. So flake here just says that there is something defining a development shell over here. I'll just use that. And the function that we're calling is this. So it takes in 2 arguments, all the packages from the Nix repository, and something called mk shell. And the packages call package will just forward these things for me. It has a name, and it pulls in a couple of packages. It pulls in 2 different compilers, some build tools, and 2 libraries that we might depend on. So this is all that's needed to actually set up an environment using Nix. So let's look how this looks. So if we look at my shell, this is a Ubuntu machine. It actually has a GCC installed because Ubuntu pulls in lots of stuff. But let me enter my simple environment. Now I do add -c means execute this, so I execute bash --no-rc. The reason for that is that if I don't do that, bash will look at my bash rc and pull in all the stuff I have in there, which I don't want, at least for this demo purpose. So here I have a different GCC version that's pulled in by Nix. If you look at this, there is not Git. I'm not pulling in Git here, but I still have access to Git. And if I look at where things are, by the way, is this readable? Which GCC? Now, one fun thing about Git Nix is that everything will be in weird places on your file system. Everything will point into the Nix store. So you see GCC, you can find that here, which is a weird location. But if I look for Git, let's see my Nix profile bin Git. I don't want that. I've explicitly said that I want a development environment. It should pull in only what I actually want and need. So the way to do that is to add the -i, and that will not pull in any other environment variables. It will wipe your parent shell's environment variable and just set up Nix's. So when I'm in here, I have the same GCC, but Git is gone. So what I can do here, and I have to delete the out folder. So here I pull in Meson as the build tool, or build environment, and I basically set it up. And I can do Meson compile, and it links some main. Now I can do the SHA sum of main, which is something, and this on this machine it will be reproducible. If I do the same again, Meson setup out. Now, of course, the SHA is going to be gone, but we'll get to that. Oh, it's actually on top here. So I'm just copying that. SHA-256 sum main, and this is the old one. So see, those hashes are the same. On a different machine, it will actually be different in this shell. And the reason for that is that the Nix shell right now adds this thing to my R path, which is not ideal. I'm not really sure why it does it, but since it uses my username and my full path to wherever I started the Nix shell, it's not going to be reproducible between developers or between machines. But the rest of the, if that had been removed, it would be bit by bit the same, and we'll see that in a bit by actually removing it. Because the environment that they're building in is the same, except for that LD flags, which is adds, and it's kind of annoying, and I don't know why. I'll try to figure out why. But you can use the exact same thing to make an actual reproducible build. Because when you let Nix do the building, it builds everything isolated, make sure every path is the same, and the --no RC is not necessary when building because it will never load in the parent environment or bash RC. So all builds in Nix are sandboxed and isolated. Now, to make this a build, from the flake side of things, we kind of do the same thing. We call another path. We call this just simple derivation. And we add it to packages. So both of the simple derivation and simple is checked into the Git repository, and we just call them from flake to allow them to do their thing. And this is slightly more complex. So NK derivation is like the basic building block for making what we call a derivation. It's a package. It has a name, it has a version. We can fetch stuff from GitHub. This is checked into source control, and in this we are pinning it to a certain revision. And we're also checking that we're actually pulling in that when we're downloading it, we're downloading what we expect. Then we have what we call native build inputs, which is build environment, like stuff you need while building, and build inputs which are necessary while actually running the application. What you might see here is that I'm not adding in any compilers. That's because the std-env is what pulls in the compiler for me. std-env is the standard environment. The standard environment, the one most people are using, is pulling in GCC, but you can easily swap that to Clang if you want to. So, if you want that to work, I just have to exit here, and I build the simple environment. And that built everything for me. Now I have in result bin main. there's an application which has now a new SHA because the LD flag is gone. But this is running on Ubuntu. But here I have my computer at home. This is running a different kernel. It's running a NixOS Linux. So let's build here as well. The exact same code. Now, I don't expect you to sit there and remember all SHAs. But this is the SHA I got on my Nix machine, and it's the same as I get on this Ubuntu machine. So the two environments that are set up, even though they're running in completely different computers, are actually the same. And you can keep testing if it's actually reproducible by adding -- rebuild -- keep failed. That triggers it to actually do the rebuild of the package, which takes not too long, luckily. And you can do that as many times as you want to see that the results are the same. Now, one interesting thing about the paths for Nix, if you saw my which GC, yeah, you don't have that here. Here you have that. Which Git. Yeah. You saw it pointed into the Nix store. And if you look at the binary, you see that the binary will look into the Nix store to find the libraries you need. So this might be an issue, because I'm not writing software to run on Nix. I'm writing software to run on generic Linux devices. So what do? I can't ship this to a customer, right? Well, you have tools in Nix to fix this. You can pull this into a container, and like from a flakes perspective, it looks very similar. The one difference here is that we're actually sending in an argument. In this case, basically just what we want to package. And the Docker container pulls in that and just say, okay, so for Docker, you give it a name like you do for any Docker image. You give it a tag. And then you just say that, okay, when I start up this Docker container, this is the command I want to run. And then this function will make sure that, okay, then we're pulling in both the application itself and the libraries that this application depends on. Which is pretty nice, actually, because you can just do Nix build. So I want to build my container, and then I can load that into my Docker, and it's so it loads in the layer, and then you can do Docker run. I can then run my application in a Docker container. And of course that container, that can be shipped out. So now we kind of denixified it, or at least made it possible for non-Nix to consume. But what if I hate Docker? I don't like this whole container thing. You can also bundle it into an executable. what that does is it basically takes all the Nix paths that you depend on, puts all of that into a shell script, and you can execute that shell script and it will unbundle itself and be able to run. So it will keep all the dependencies. So all the dependencies will still be pinned. It will use the exact same binary, and it will use the environment that we created using Nix. So we can do that by Nix bundle, and we can do that directly on the application that we want to bundle. And then on Linux, this will use namespaces to set up the environment without actually having any effect on the parent environment. And because this is a work computer and it has some limitations, I have to actually run this as sudo, which is annoying me a lot. But it feels like a regular application at this point, even though it is just a shell script where we pull in binaries. So this one will set up namespaces, rewrite the file system for the application itself, and then run itself. And all of this, also the shell itself, is using the same techniques to avoid polluting the parent environment. It only creates its own isolated environment, and the parent environment is completely unaffected. Oh. But I did speak briefly about something called NixOS, and having a reproducible OS, which is kind of neat. And this is definitely taking it a step further from building a package. Because now you can make a reproducible OS. You can put that OS onto a device. So at home I have a couple of Raspberry Pis which are using NixOS, which I build on my host machine, and I just put them directly into the Raspberry Pi. And that Raspberry Pi I can swap out and they'll just work exactly the same. So NixOS is a Linux distribution, and it is based on the Nix package manager. You get a reproducible configuration of, or a declarative configuration of the whole operating system if you want to. You can also do quite a few things the old-fashioned way by writing your own config files. But the idea is that you write your config files and you define what packages you want in this Nix language. And that will then be able to recreate the config files on disk that you actually want. And as long as every step here is reproducible, your whole OS will be reproducible. And you can go back in time to when you liked your OS, rebuild it, and it is the exact same thing. So I use this on all my home machines, and all my machines feels exactly the same because they're built from the same source, from the same Git checkout, with the same configuration, but with some changes, like some services I have on some machines and others I don't have. But everything is built from the same source and from the same Git checkout. So to make a reproducible VM, you add this NixOS configuration to your outputs. So this defines a configuration which is an OS. The host name of it will be my VM, by default. You can override that if you want to, but the default is to use the name on the left-hand side here. And you call this NixOS system function. You tell it what system you're building for, and then it calls. You can have multiple of these modules. Here I have one module, so the module I made is this one, and this is a function call. Well, this is a function which will be called. It's a very simple little VM. All I pull in is vim and git, because that's all you need. And then I create a user, which is using my username, and I give it a password, which is NDC Oslo. Put it in the wheel group. Not really much to this. And you can configure this quite a bit more. So this part is kind of interesting, because at the end here, there is a Linux system, like a regular Linux system, with PAM as login. It uses standard login features of Linux that is used on any other Linux system. So this Nix expression is going to translate into something that is put into your user config file, your passwords file, your shadow file in a regular Linux system. So you're basically writing, this is instructions on how to write certain config files. And this is pretty cool. So now I can do NixOS rebuild. This is a different command. Oh. Nix packages. Oh. NixOS rebuild. Okay. This I should probably have done before. So now I'm pulling in the tools I need to build our OS. Because then now you can't use the Nix command anymore. You have to use the NixOS rebuild to build the OS. Come on. Nothing ever feels as long as when you have people waiting to see what's happening. Okay. I thought I had this cached, but I didn't, so... Okay. There we are, nice. So now I can do NixOS rebuild, build VM, my VM. Didn't I pull in? Okay, not sure what's happening here. I'll create it here, but the problem is that we're not gonna be able to actually see the VM here. Just making a VM. Just check one thing. NixOS rebuild. NixOS rebuild. Let me see if this works. I want to show you the VM. Build VM. There we are. So now it's building the VM itself. Or it's building the NixOS distribution that I created, or the NixOS configuration as a VM. So the nice thing here is now I can go into the result, and there's a bin which allows me to run this VM. Let me just make this more visible. Zoom to fit. Okay, is that visible for anyone? And I can log in. It's a full Linux distro. It's running kernel 6.12. I can open Vim. I can use Git. I don't have GCC or Clang or anything like that. It's a very bare bones VM. But from this many lines of code, 27 lines of code, I can now build up a full Linux system, which I find kind of cool. And this Linux system is, as with most things here, fully reproducible. I can build this on several devices, and as long as they're the same architecture, they will end up with the same VM. But there are, of course, problems. And my first reaction is, am I really saying here that Nix is not perfect in any way? It's Nix is great, but there are some sharp edges. The sharpest edge is probably the Nix store, or the way it sets up its paths. Because that means that it's using a non-standard file system hierarchy setup. So what if we need to use pre-built binaries? What if someone made something, closed source, they build it for Ubuntu, and they publish it? I can't use that, because they're gonna look in userlib. I don't have userlib, like it doesn't exist. I can prove that. Userlib. My user is this on an NixOS system. I can't use any of these things. So, of course, there are solutions to this. But for me, I work in an embedded environment mainly. We use a lot of pre-built toolchains. They are made for some Red Hat type Linux, and it expects the file system to look like a Red Hat file system. Or actually, FHS, the file system hierarchy standard. That's what's coming in to bite us here. There are some rules and standards for where files and directories are supposed to be on a Unix system. And most distros are kind of compliant, and Nix doesn't care. I think there are basically two applications that are on a expected place on Nix. That is user bin env and bin sh. So the most basic shell and the tool for finding out environment variables. So for Nix, we then have two options for making these applications work. We can change the RPaths for binaries. RPaths is where the binary will look for its libraries. Or we can use what is called an FHS environment. So we can rewrite our file system to look like what the binary expects. Now, changing the RPaths is very useful. It's very useful. Useful for most binaries, basically, and it's the default way of fixing this problem in the Nix packages repository. And it is the go-to way to do this. It forces the linker to search in the Nix directories instead of like the standard directories that it's compiled into. But it does change the binary. It rewrites the binary, which someone might not like. But I kind of like it. So here I have a recipe for building FlashPrint, which is a 3D printer software for FlashForge printers. What we do here is we, well, again declare where to fetch the package from. And in this case, the package is a deb file. that indicates that it's kind of made for Ubuntu, which means we can't use it. And the key part of this derivation is that we're adding auto patch elf hook into the native build inputs. And that adds an extra step into the build, which goes through every binary for this derivation and rewrites them. And it does that unconditionally. You can write your own build steps, which will just take the binaries you need and the libraries you need. This will take everything. It is kind of brutal. So all I do in my build steps is I unpack the deb package and I move the resulting binaries to out, which will be somewhere in the Nix store. And then I let auto patch elf hook do the work, because I'm lazy. So we can then, oh, this is the wrong one. Let's kill the QEMU. I think I called it flash print. So next build flash print will build the flash print thing, and it will run the auto patch elf hook. This is going to be from a deb file, but if you look at the result, this is in. Look at the result. You see that it is now pointing into the Nix store. So what you're interested in here is the where it looks for the packages. So libexile it looks for in Nix store. So I rebuilt all of this for this package, which previously looked into userlib. I can actually let's do this to prove that I'm actually not screwing with you guys. Because I have time, right? Yeah. So I download it. Of course, downloads takes forever. If I was a smart man, I would have done this beforehand, so I didn't have to sit and watch this progress bar. But okay. And now I have to cheat and look at what the recipe says. Dash X. What? Wasn't this? Dash A. Ah. It wants me to unpack it here. So this is the binary I pulled in. And there is user share flash print, because I haven't done anything with this binary. I haven't done anything. Nix has done quite a lot. And if I look at this flash print, you see it's looking in /lib. On this machine that works because this is a Ubuntu machine, so it finds most of it, not all of it, because I don't have Qt installed. But after running it through Nix, you see that I've basically rewritten everything. Okay. To look into the Nix store. So this is one way, and probably the preferred way, to take pre-built binaries like this and put them into Nix. But as always, there are problems. For instance, at work for me. So we have a bunch of tool chains that are pre-built that we pull in and that we need to use to build our software for different architectures. Because like I said, I work in an embedded environment. Now these tool chains are meant to be run on our build machines, which are some Red Hat thing. And so they are following FHS, and I'm not. And I can't rewrite these tool chains for everyone. and pulling them into my Nix environment and rewriting them is quite a bit of work. So that gets us to creating an FHS environment. This does not change the binary, which in some cases is a good thing. And it allows the linker to still like search in standard paths. The way it does this, because it feels weird to rewrite the file system, but it only does it for this application. And to do that, it uses Linux namespaces, Linux user namespaces, and Linux mount namespaces. There exists talks both from me and from Michael Carrick about namespaces. If you're curious about how this works, it is actually really cool. Because you can then rewrite the full file system for an application without anyone else noticing. And that's what's happening here. So, to do that, I actually show you. I didn't show you. So, FSH, I forgot to put this into the slides. Some things are a bit last minute. So, this is how you would do that. So instead of the MK shell that we've used previously, or MK derivation to make a derivation, we now use this build FSH env. That also has a name, and it adds some packages. In this I said multi-packages because then they're both 32 and 64-bit. You don't have to do that. You can just use whatever for your architecture. I pull in a couple of packages, and that's how I create my environment. And you might have noticed that I went over to my NixOS system instead of my local Ubuntu thing. Because here I don't have Git. My file system is weird. There's this NixOS bootstrap. lib64 is actually there, but there is very little in it. There's some linker stuff, nothing in lib. User is almost empty. Like I said, user bin only contains env. But if I enter my FSH and shell, then my file system certainly looks different. Both have lib32 and lib64. I have an init folder. Where's my mouse? There it is. I didn't have that before. You see what I had before. If I look into user bin, I suddenly have lots of stuff, where I previously only had env. And to prove that I haven't changed anything, this is the computer I'm using. My parent shell still only sees env. But here I have git in, well, in this location, because I didn't put it in git, but I have pulled in GCC. And you see it's in user bin GCC. That's where you kind of expect GCC to be. You have libraries in user lib. You don't even have a user lib here in the parent shell. So for this application, this shell that I'm running on top here, I completely rewritten the file system, or not completely, but I rewritten important parts of it to be able to run whatever I want. Now, of course, are there alternatives to Nix to do kind of the same-ish things? And there are. There are some Nix forks, or not all of them are forks, but the The two topmost, they are pure forks. They want to keep Nix as is basically, but they are introducing different governance models for the Nix packages. There have been some controversies about the governance model of Nix. Twix is a full rewrite of the Nix interpreter into Rust. There's still a feature gap there. Might or might not be a good idea. I'm not really sure. But there are also completely different systems which try to solve the same thing in different ways. So Tangram and Brioche are kind of derivations of each other. A couple of developers from Tangram went in and started Brioche. But they are using TypeScript as the language instead of Nix. But they are trying to solve the same problem in sort of the same way, but with a different language. Gix is probably the most mature alternative to Nix. It's a GNU project. Instead of Nix, it uses Lisp, or more pedantically Scheme, as the programming language. So if you like that, then Gix is probably for you. Being a GNU project, using Lisp makes sense, as all they do is Lisp. But this is pretty stable. Someone else that's been here this week, he told me that Gix is Nix done right. I haven't used Gix, so I can't verify or dispute that. But I have a new wormhole to start digging into. But it does have very big similarities and also some very key differences. Thank you all for coming. Are there any questions? I see we have 3 minutes. And I still can't see you, so if you have any questions, just shout out and I'll repeat them. Okay then. I can't hear you, I'm sorry.
How can building NixOS with different architectures? Say your main PC is x86.
Yeah.
And manage what with ARM.
Yeah, so the question is, how does Nix play with different architectures? With, for instance, your main PC being x86 and then, for instance, building for Arch64. Was that the ARM? Yeah. So yeah, I actually do that. Like I said, I have a couple of Raspberry Pis. Nix has some support for cross-compilation. Cross-compilation is difficult on some projects, so your mileage might vary. But it has very good support for building inside of QEMU. So you would normally what I do is I fire up I don't. Nix will fire up a QEMU image where it will build all my stuff on my host. If you have a powerful enough ARM device, you could of course build on that. You just build an initial ARM image to bootstrap it, and you're good to go. But I have several ARM devices that I use at home that are all running NixOS. Any other questions?
Have you published your Nix configuration?
Yes, it is on my GitHub. So if you look at GitHub martiat/NixOS config, you'll find my full NixOS configuration there. It is 2 repositories because I have a separate one for work, but they are pulling in a 3rd repository that has some common stuff. But that is public. Okay. Thank you all for coming.